Calculus kids, this is Dr. Callahan with Week 8 Friday. How are you guys doing? You made it to the end. So go ahead and pause the video and answer the following 3 questions. So you have exactly 5 more school days before your warm-up block is due. If you have any of the blank boxes, I will highly recommend that you just go to MS Team, look into which week you're missing in. It's usually notated on the warm-up block itself. Watch the videos of the beginning of those days and weeks that it's missing, and then fill out the blank boxes. It's 300 points, and that's going into your grade book. Most likely, you will probably get a fairly good grade because you guys are all calculus kids, and I know you guys are doing really well. However, and most likely your grade will probably increase. However, if it's going to decrease, this really is a good opportunity, like a week ahead of time, for you guys to go ahead and ensure that it is done accurately. All right, so today we are going to be doing a review of all integration concepts and strategies. Make sure you guys are checking in with me by 9:41. 9:41 a.m. So to ensure that you are being marked present. And I'm just gonna go ahead and sign this. Excuse me. All right, so with that said, let's go ahead and get started. So looking at this right here, just to give you guys an idea as to where we are and how this is going to progress with the remaining of the school year. We are currently on the 26th, which is the Friday. And so after this week, you have, and this is week 8, by the way, then you have week 9, week 10. After week 10, so in 2 weeks, you guys have spring break right here. Then when you guys come back from spring break, week 11, week 12, week 13, this is the last day for the new content. And after week 13, we are no longer focusing on Math Excel anymore. We're going to be focusing on Albert IO for week 14, 15, and then your week 16 on that Tuesday, May 4th. Oh yeah, how interesting. If you're a good or a huge Star Wars fan, May the 4th be with you on May. That's when you're going to have your AP exam. So it'll give you a good 2 weeks of being able to kind of review all the concepts after the last day we talk about anything new. We're going to end the semester with volumes of different methods like shell method, disk method, etc. There's a washer method. No, there's no dryer method, and we will just continue on with that. So this is kind of a glimpse as to how this is going to move forward. And then when that's done, you will have week 16, 17, 18, 19. And then, of course, you'll have week 20, which is the week of the finals. So then between 16, 17, 18, and 19, you have about a good 3.5, 4 weeks. And this is when you're going to be working on projects for this class. So that's kind of the breakdown of where we will be. All right, so with that said, let's go ahead and move on to today's stuff. So this piece of paper, I'm going to be printing out and passing it out to you in class. It's not in your guided notes, so I apologize about that. But there's no reason why you can't actually do this on your own and just copy it down. That's completely fine as well. Here is a correction form. So if you did not do so well on the Math AP College Board quiz for week 7, Wednesday, I will highly suggest that you go ahead and fill this out so that way I can increase your score for this. I would definitely recommend you doing that. You get 50% back for each question that you do improve on. Some of you guys are super duper good about getting this in, and as a result, you can probably see like your grade doesn't really dip that low, even if you made a few mistakes on the quiz itself. All right, so with that said, let's go ahead and get started with today's stuff. So first things first, I would like you guys to go ahead and pause the video. There are 12 questions. it's a combination of integration and derivatives. So I would like you guys to pause the video and answer any questions on your own, and then we'll go over some of them together. Okay, let's take a look at number one. With number one, as you can see, the numerator has a smaller power than the denominator. Generally, when the numerator has a bigger power, you would do synthetic division or long division. But with this one, you want to go ahead and match it to one of the three integral rules, but unfortunately you can't because if you look at it, the denominator is not shaped, it's not formulated in that way. So I'm going to go ahead and complete the square. Okay, so x, well, actually not just that, you also have x to the fourth, so that's okay. X to the fourth plus 2x squared plus blank plus 2 minus blank. Take your middle number, which is going to be 2 divided by 2 squared, which is 1. So plus 1 minus 1. Now, this piece right here is going to be x squared plus 1 squared. And if you do FOIL it, it's going to give you x to the fourth plus 2x plus 1. Now, on the other hand, this part right here is going to give you a plus 1. Now, think back. Which one is it going to match, do you think? You have 3 of them. You can flip back to your guided notes and take a look to see if you might have some of the 3 that you have. Remember, 2 of them have square roots, 1 of them doesn't. I'm taking a moment to find the formulas, hoping that I can just cut and paste it over so that way you guys visually can see it. But I'm having a little bit of difficulty loading this, and it's just taking a little bit longer than I would like. But no worries, I am almost there and it's almost done. Okay, I got it. So I am back. Let me just paste this here. Okay, so then looking at this right here, I think this one it looks very familiar to the tangent one. Which is this one right here because it doesn't have a square root. So let's go ahead and see if we can maybe perhaps match it. All right, so here you have a squared, or actually you want to reverse this, u squared plus a squared. So you know that your u is going to be x plus 1, du is going to be a dx, and then your a is going to be 1. So let's rewrite this then. So rewriting this, I have an x over, oh, I'm sorry, x squared. Yeah, that does make a difference. The derivative is 2x, so then your dx is equal to du over 2x, which is perfect because it cancels down to x. On the bottom, u squared plus a squared. Change the dx with a du over 2x. And cross that part out. You have a 1/2 on the outside. You have a du over u squared plus a squared. And if you look at this, this is perfectly aligned with what I have here. So then you can just plug into the equation. Equals 1/2 integral u over a. So arc tangent u is going to be x squared plus 1 over a. A is 1 plus c. And that is your answer. All right, let's take a look at example number 2. Well, example number 2, notice the numerator is bigger, has a bigger power than the denominator, so you would have to go ahead and use division. So x cubed plus 0x squared minus 6x minus 20. So you're going to fill in anything that has a blank, like x squared, for example. On the bottom, it's just x plus 5. Okay, so x times x squared is going to give you an x to the third plus 5x squared. Subtract it, you get a negative 5x squared, bring down the negative 6x. Next, you're going to put minus 5x, distributed in, negative 5x squared, minus 25x, subtract it, that's a positive 19x minus 20. Next, I'm going to put a plus 19, distribute it, 19x, plus, that's a 45, that is a 5, so 95. And if you go ahead and subtract it, you will have a negative 115 because you're the distributive negative. So your answer with this is always going to be the quotient, that's the quotient, plus the remainder, that's remainder, over the divisor, and that's a divisor. Okay, I just like to remember it's like Q plus R over D. So if I were to rewrite this, I would just have x squared minus 5x plus 19 minus 115 over x plus 5. Okay, so the first three terms is pretty simple because you're just going to apply the integration, like the reverse power rule. Plus 1 equals 3 divided by 3. So equals 1 over 3 x cubed. 1 plus 1 equals 2 divided by 2 minus 5 over 2 x squared plus 19x. But then when you do the integral of the fourth term, this one will require you to do a u substitution. So I'm just going to say let u be the denominator, x plus 5. du is dx. And then if I go ahead and rewrite this, I have a minus, and actually let's do it over here, minus 115 over u, change your dx to a du, minus 115 integral 1 over u du. And you know that this is going to be ln u. So minus 115 ln u, and what is u? X plus 5 plus c. And this right here is going to be your answer. Okay, let's skip number 3. I'm going to go over to number 4. For number 4, this is the review where you have to find the derivative of the arcsine, where you have to work from the inside out and then draw the triangles, if you remember that. So the first thing you're going to do is you're going to put y is equal to arc sine t squared. Then, because you have a sine right here, we're going to put sine on both sides. So sine y equals sine arc sine t squared. And with that, what ends up happening is your arc sine and your sine cancels, and you have sine y equals t squared. Now let's go ahead and find the derivative of this. Anytime you find the derivative of y, it's a dy over dx. Derivative sine is a cosine y. dy over dx equals 2t. Now I want to solve for dy over dx, so I'm going to divide it. Divide the cosine y on both sides. And then looking at this right here, remember you always have to go back to the main original equation. Here it's saying y is equal to arc sine t squared. And do you see the y right there? Well, you're going to go ahead and replace that with this piece right there. So that's equal to 2t over cosine arc sine t squared. Okay, so now what we're going to do is we're going to work from the inside out. So draw your triangle. Here's your triangle, okay? You're going to look at it from this perspective. Now, cosine is going to be adjacent over hypotenuse. And oh, I'm sorry, you're not looking at it from cosine. Sorry. That's where you're going to have a fine at the very end. You're looking at it from the perspective of sine. So sine, because you're working from the inside out, sine is opposite over hypotenuse. And if you look at this right here, it's t squared over 1, opposite, hypotenuse, adjacent. So opposite is a t squared, hypotenuse is a 1. Adjacent is always going to be hypotenuse squared minus opposite squared, which is going to be 1 minus t to the 4th power. So then looking at this right here, now you're looking at it from cosine. Remember, cosine is adjacent over hypotenuse. So cosine adjacent over hypotenuse is going to be square root of 1 minus t to the 4th over 1, or just square root of 1 minus t to the 4th. So if I replace the cosine with that, I have a 2t over the square root 1 minus t to the 4th. And that is your answer. That is your derivative for this equation. I know it's been a while since we talked about that, but it's important not to forget it. Okay, let's go ahead and take a look at number 7. Number 7 is actually not really difficult. I'm just going to give you guys the derivative answer for this. The answer is just going to be f of x is equal to, and actually, you know what, it might be easier if I just copy and paste it over. So give me just 1 second. You could pause the video, give this one a try, see how far you get into it. Okay, so here is your answer. I apologize about the quality of the video itself. In addition to that, I'm going to go back to number 3. So I can also include the answer for that one. So we're just going to go back to number 3, and you guys can take a look at this one for number 3. So pause the video. All right, so let's go on to the next one. All right, let's take a look at number 8. With number 8, I see a square root and already has a square. So immediately I'm thinking, okay, what's an integral? So I'm going to use one of the 3 formulas. So just based on looking at this one right here, which one do you think you are most likely going to use? All right. I think it looks very similar to well, I can say that it kind of looks like the arc sine because they both have a square root, or it could also be the arc secant because if you look at it, you want u to be e to the 2x. So I'm thinking it might be this one, whereas here it's a negative u squared. So it's either one, but let's see where we get to. So let's go ahead and do a u sub and say u e to the 2x. And actually, no, I'm sorry. If it's going to be the third one, you want u squared to be that. So then u would just be x. So then your du would just be e to the x dx, and then dx equals du over e to the x. So let's go ahead and substitute it back. Integral, change your dx with du over e to the x times the integral of, well, you have your u squared right there, minus a squared, and you can tell that a equals just 1. And as I'm starting to look at this, isn't e to the x just u? So it's actually looking more like your formula 3, okay? So now that I have everything in this format, I can just go ahead and replace it with the formula here, which is 1 over a, so 1 over 1 arc secant u, which is e to the x, over a, which is 1 plus c. And that's your answer. So that one was actually not too bad. But you initially might have thought it was this one, but guess what? It wasn't. So it just kind of flipped on you a little bit. All right, you guys, so we went over several of these. I'm going to have you guys continue on just working on the rest of them. And then if you have any other questions, make sure you can ask me in class, but go ahead and practice with these. And let me see if you guys just pause the video for a second. I am going to give you guys the answer for the rest of these. So I'm just going to show you guys the answers for the ones that I didn't go over in class. So this is number 3. Go ahead and pause it. Here is for number 9. I'm going to move on like now. Here's number 10, 11, and number 12. And again, they're not any more difficult or less difficult than anything else that we've gone over. It's very similar to some of the ones that we've gone over in class and also for today. So I would just recommend that you guys go ahead and practice with this for today. All right, you guys, as always, stay safe and healthy, and I'll see you guys next time. Be kind to one another. Take care.